All right, hello, fellow TCNJ math teachers and professors. I just wanted to get your opinion on an equation before we go back to school. And this is an interesting thing that's come up throughout the years, and I just kind of realized something this summer for the first time that I never thought of before with one of the methods for solving this equation. So, you're teaching Algebra 1 or Algebra 2, you might recognize this equation is quadratic. Your students will hopefully see that. And, there's different ways to solve quadratic equations. Obviously, first you might see some factoring, where we could, move the 98 to the left-hand side and we can factor. I'm not primarily concerned with that here, but you could do that to find the solutions or find the values that make it true. Graphing is cool, and if you have Dr. Safi's new book, you may have seen this in the introduction or the first chapter. I forget where it was, but it's actually pretty cool. He says, consider, any single equation, you can look at it as a system. And in your calculator, you do y equals left-hand side, y equals right-hand side, graph both at the same time, and the x coordinates will be your solutions. And that'll give you, the students, a taste for what's going on. And you can ask good questions like, well, what's that left-hand side? What shape is that going to make? And hopefully they'll recognize, well, that would be a parabola. And the right-hand side, y equals that. What shape is that going to make? Horizontal, vertical line. They have to recall correctly. That would be, a horizontal line. So right away from that, you can see that there has to be two solutions. But that's not even the method I want to pursue right now. So taking square roots, this is where constant trouble comes to my students and, to my own understanding too, as I think about this more. But let me see what you think here of what the best way is to show this work and to do it properly. If we're going to take square roots, I usually teach my students to isolate the squared term, or that which is being squared. Technically, the 2x squared is one term, so I should say isolate the thing being squared. So here the x is being squared only. The exponent only applies to what it's directly next to, unless there's parentheses. So we can divide by 2, because that 2 is not being squared. And we obtained x squared equals 49. Okay, this is where all heck breaks loose for my students. We even had a multiple choice question one time where they had to say, okay, the square root of 49 equals, and about 75% of the class got that wrong. The answer is 7, as you know. But how can you show the work from here, and what exactly is going on? That's what I want to just pursue for about a minute. So bear with me here. And I'm going to tell you what I used to say and now what I'm considering saying based on what I learned this summer, and you can tell me what you think. Okay, what I used to say is when you have the squared thing, entity, term, when you have the squared part isolated, you can then take the square root of both sides, because square rooting undoes the action of squaring, or taking a square root is the inverse operation of squaring. Now, so that my students could, follow their work and kind of annotate it sometimes, I would even rewrite this step before I did the action of square rooting. And then I would do a square root. And then, I would tell a little story about the fact that, well, when you take the square root of x squared, here on the left-hand side you have x, and on the right-hand side, square root of 49, they've learned, well, this looks like a principal square root symbol, and so it should just be 7, because the square root of 49 is 7. But then, we usually think about, but when we're solving an equation, we have to think of all the things that could make it true. What are all the things that would make this line true? And usually someone will be able to come up with another number that when squared will equal 49, and namely that would be -7. So by intuitively thinking about this step, we come up with the idea that, well, when we do the action of taking the square root, or when we introduce a square root symbol, we have to include a plus or minus sign on the right-hand side, because both the positive answer and the negative answer will be true. And perhaps, that seems right as far as it goes. Maybe you write the answer in a solution set, and it's -7 and 7. However, my students inevitably get confused and will either forget to do the plus or minus sign, or from now on, when they see things like the square root of 36, they'll think that that needs a plus or minus sign, and it doesn't, because that symbol is just the principal square root. So then I get all fancy. I'd introduce this whole noun verb distinction. Well, when we just you don't have to talk about nouns and verbs, but when I say, well, when you just got a square root sitting there in a problem, something like this, well, that means the positive square root only. It means the principal square root. That's how we use the symbol. But when you do the action of taking the square root, you must introduce a plus or minus sign. The verb is different. And I used to say this for a while, and some students got it. Others would inevitably still be confused and get the question incorrect. But it got me thinking that this, noun-verb distinction, a square root sitting there versus the action of taking square root or introducing a square root, was kind of an odd thing to say in math. And maybe that's why the students are being confused. Maybe it is, maybe it's not. But in no other context would really this apply as far as operations. Let me tell you what I mean. We would never say, okay, when you have an addition sign here, x plus 2, well, that just means regular old x plus 2. But in a different context, when you do the action of adding 2 to both sides, that really means something different. Well, no, it doesn't. The plus sign here and the plus 2 here, what you're doing is a little different, but the plus sign still carries the same meaning. Similarly with subtraction, and similarly with multiplication or division. You wouldn't say, okay, when you have 2 times x equals 10, that's one thing, but when you do the action, let's say, of multiplying both sides by 2, the times 2 really means something else. No, it's just a weird thing to say. So maybe that's why it's unusual a little bit for students. And so that got me thinking further of whether that was actually correct at all. That the square root sitting there is actually different than doing the action of introducing the square root. And it's really not. If you look at any old-fashioned Algebra 2 book that might show you the properties of square roots and radicals, etc., or some Algebra 1 books would have it as well. But what you're really doing here, and a lot of you probably know this, well, what happens when we choose to introduce a square root symbol? It's not that this symbol is different because we're doing an action. This is the principal square root symbol introduced on both sides. It is no different. It's just like when you add and subtract on both sides, etc. However, so therefore the right-hand side is equal to 7. The student's intuition is correct. But what's the left-hand side equal to? And that's where those of you who've done Algebra 2, pre-calc, calc, etc., you'll recognize that the square root of x squared is not equal to x, but rather the absolute value of x. And this is the missing step when we tell students that, well, when you take the square root, you really need to introduce a plus or minus sign, because absolute value of x will mean the distance x is from 0. And when is x 7 units from 0? Well, it's 7 units from 0 when it's at positive 7 or it's at negative 7. Or as you may have taught them on number lines, you have to split up an absolute value equation into 2 equations, etc. So this is kind of the missing culprit to this whole thing. And I was just curious if any of you show this step in Algebra 1 or Algebra 2, or if we should consider doing that, or if we should just, keep with the noun-verb distinction, go right from here to here and explain why it's true. I'm not saying it's wrong to do that. I'm just saying we're technically skipping this in-between step algebraically, and maybe for good reason. Maybe that would confuse the students even more. But if you get this idea, and you've talked about it earlier in the year, that the square root of x squared is equal to the absolute value of x, then I definitely think it might be worth it to include that step. Okay, just wanted to know your thoughts on this as I prepare to teach, Algebra 2, Algebra 1, and see what you folks are thinking. All right, thanks for watching, and have a good start of the year.